Welcome back to the .NET Way. You are watching episode 23 of our .NET Core interview series. Over the last few episodes, we've covered massive enterprise concepts like CI/CD and Docker. But today, we're looking at something incredibly lightweight and modern. We're doing a 20-question deep dive into minimal APIs, one of the most popular features introduced in .NET 6 and expanded in .NET 7 and 8. Are traditional controllers dead? Let's ask our senior developer Arohi. Welcome back.
Thanks. This is a great topic. Minimal APIs completely changed how we write C# web services, so I'm excited to break this down.
Arohi, let's start with the basics. What exactly are minimal APIs?
Minimal APIs are a lightweight way to build HTTP APIs in .NET without the full overhead of the traditional MVC, Model View Controller framework. Instead of creating separate controller classes and dealing with heavy routing attributes, minimal APIs use a concise, functional syntax. This makes them ideal for microservices, prototypes, and cloud-native applications.
What does a typical minimal API route actually look like in code?
It's incredibly simple. All the routing happens directly in program.cs. As you see here, there are no controller classes, no route attributes, and no HTTP GET decorators. It's just map get, the route string, and a lambda expression returning the data.
Why would a senior team choose minimal APIs over controllers?
There are three main reasons. 1. Less ceremony. Fewer files and boilerplate code make the project much easier to navigate. 2. Performance. Because they bypass the MVC middleware pipeline, they have faster startup times and lower memory allocation. 3. Accessibility. The syntax feels very similar to Node.js Express or Python Fast API, making it much easier for non-C# developers to learn .NET.
What are the trade-offs? When do minimal APIs struggle?
If not managed properly, minimal APIs can turn your program.cs file into a massive, unreadable mess of thousands of lines of code. Also, traditional MVC features like built-in model state validation, complex custom action filters, and content negotiation are slightly harder to implement manually in minimal APIs.
In controllers, we use constructor injection. How do we inject services into a minimal API?
It's even easier. You just inject the service directly into the parameter list of the Lambda handler. The .NET runtime automatically recognizes IUserService from the DI container and resolves it perfectly, without needing a class constructor.
How does model binding work for parameters?
You pass them exactly the same way. The framework infers where the data comes from. Here, the ID is automatically taken from the URL root, while the filter value is automatically read from the query string. For example, filter equals active.
What about receiving JSON payloads from a client?
Minimal APIs is automatically deserialize JSON bodies into C# objects using system.text.json. Simply declare the user DTO as a parameter. The framework reads the HTTP request body, converts the JSON into a populated C# object, and passes it directly to your Lambda function.
In that last example, you used results.created. What is IResult?
In MVC controllers, we usually return an IAction result, such as OK, not found, or bad request. In minimal APIs, the equivalent is the IResult interface, which is created by using the static results class. It lets us return the appropriate HTTP status code along with the response data.
Our minimal API is secure. How do we lock down endpoints?
Yes, they hook into the exact same authentication middleware as controllers. Instead of using an authorize attribute above a controller method, we simply chain the .require_authorization extension method to our endpoint map.
Since minimal APIs don't have model state as valid like MVC controllers, how do you validate incoming requests?
In minimal APIs, validation is mostly done manually or via third-party libraries. The industry standard is to use FluentValidation combined with a custom endpoint filter to automatically validate incoming JSON models before the Lambda ever executes.
You mentioned endpoint filters. How do they compare to MVC action filters?
Endpoint filters were introduced in .NET 7. They allow you to run code before and after a minimal API endpoint executes, perfect for validation or logging. It intercepts the request, lets you inspect or reject the parameters, and then calls next to continue the pipeline.
If we have 50 user-related endpoints, won't program.cs become a mess? How do we organize it?
We use route groups, which allow us to apply common prefixes and middleware to a set of endpoints. Now, both of these endpoints automatically live under the /API/users path and require authorization, keeping our code incredibly clean.
Can we move those groups out of program.cs entirely?
Yes, the best practice is to write extension methods on the endpoint route builder interface. We create a separate class, say userendpoints.cs, define the routes there, and simply call app.mapUserEndpoints inside program.cs.
Does Swagger OpenAPI still work with minimal APIs?
Absolutely. You register Swagger in DI just as you normally would. To create rich API documentation, you simply chain extension methods, such as producers of T, to your endpoints. This tells the Swagger UI exactly what HTTP codes and object schemas this specific endpoint can return.
What are typed results and how do they differ from the standard results class?
Typed results are a massive improvement for testing and OpenAPI generation. If you use results.okUser, the return type is IResult, so Swagger doesn't know the exact object type. If you use typed results.okUser, the compiler knows the exact type, making unit testing the endpoint much safer and automatically generating better Swagger docs.
Do we have to choose one or the other for a project?
Not at all. Minimal APIs and MVC controllers can coexist in the exact same application perfectly. You can use minimal APIs for high-performance simple microservices while keeping heavy, complex UI logic inside traditional MVC controllers in the same project.
Is there actual proof that minimal APIs are faster than controllers?
Yes, the official Tech Empower benchmarks show that .NET minimal APIs consistently rank among the fastest web frameworks in the world. Because they avoid the heavy reflection and pipeline routing of MVC, they process requests with significantly higher throughput and lower memory overhead.
You mentioned complex model binding earlier. What is AsParameters?
If a minimal API needs 10 different query parameters, putting them all in the Lambda signature looks terrible. AsParameters lets us group them into a single class or struct. The framework automatically binds the URL query strings into this clean record object.
How do you write unit tests or integration tests for minimal APIs?
We use the WebApplicationFactory class provided by Microsoft. It spins up an in-memory test server of our application, allowing us to send actual HTTP requests to our minimal API endpoints and assert the JSON responses without ever opening a real network port.
Final question, Arohi. If minimal APIs are so fast and modern, when should I still use MVC controllers?
I prefer MVC controllers for large, monolithic enterprise apps where you rely heavily on complex attribute routing, heavy action filters, and global exception filters, or data integration, server-side HTML rendering using Razor Pages and Razor Views. Minimal APIs are best for highly focused cloud-native microservices where raw performance and low memory footprints are the absolute priority.
That was a brilliant discussion, Arohi. Minimal APIs are an exciting evolution in .NET, and now our viewers know exactly how to structure them, secure them, and when to use them over controllers. If you found this 20-question masterclass helpful, hit the like button, drop your thoughts in the comments, Are you team controllers or team minimal APIs? Let us know. And don't forget to subscribe to the .NET Way. In episode 24, we'll discuss how to create and publish a NuGet package, from writing reusable code to versioning and deployment. Thanks for watching. See you next time.